Welcome to Introduction to Wells. This video will provide rural homeowners with a basic understanding of groundwater, wells, and their operation. The water cycle is the movement of water between land and bodies of water. It naturally recharges our surface and groundwater sources. Let's take a closer look at the water cycle and how our groundwater supply is maintained.
Let's get the big picture of where drinking water comes from by looking at the life history of water, called the hydrological cycle. We'll look at this cycle by starting up in the clouds. Water vapor condenses and falls as rain or snow, which are two different forms of precipitation. Then it takes one of two pathways. It flows as runoff over the surface of the earth and collects in lakes and streams. This is called surface water, or it soaks into the ground, called infiltration, and becomes groundwater. Groundwater concentrates in underground regions called aquifers. To use this water, we drill wells. Some water from aquifers flows into lakes and oceans. There, it becomes surface water. Some surface water will evaporate and return to the atmosphere. Surface water also flows to the oceans, and some evaporates back into the atmosphere. In addition, water evaporates from trees and plants after being absorbed from the ground. The evaporated water forms clouds by condensation, and the cycle begins again. During each phase of the hydrological cycle, water can pick up contaminants that are harmful to people.
Groundwater sits below the Earth's surface. It is recharged by the infiltration of precipitation that soaks into the layers of soil. But we should be aware that water may not be pure. Let's watch a brief video about potential contaminants in our water.
Natural sources of water, surface water and groundwater, contain contaminants and are never pure water. These contaminants can come from natural sources. Animals, plants, and the soil can all contribute contaminants to water. Human activities can also add contaminants to water. Urban wastewater and stormwater. Industrial activities and activities on the land such as farming and forestry are just a few examples.
The most significant acute health risk to a consumer is drinking water contaminated with microorganisms that you cannot see without a microscope. Although a lot of microorganisms found in nature are harmless, it is important to understand that those coming from the digestive tracts of animals and humans can potentially cause illness and are referred to as pathogenic. The three main groups of organisms that may cause illness are bacteria, viruses, and protozoa. Bacteria are the most well-known type of pathogen and are found everywhere. While most are harmless to humans, exposure to harmful bacteria through drinking water can lead to severe illness, or in some instances, death. And just one exposure to bacteria can cause health problems related to the stomach and intestines. Symptoms can develop over the course of a few days, or after just several hours. Examples of bacteria include E. coli, Salmonella, and Campylobacter. Viruses are the smallest of the three pathogens described here. In fact, viruses are the smallest of all microbes. With few exceptions, a human is only affected by viruses from other humans, as most viruses prefer a specific group of hosts. To determine if a water source may be contaminated with viruses that could be harmful, consider this question: are there human sources of contamination present? Although it was once believed that viruses were only a concern for surface water systems, and that deep groundwater was secure from viral contamination, it has recently been discovered that viruses can not only reside in aquifers, but can travel through them with the movement of groundwater. It is possible that human contamination from elsewhere could reach your raw water source, even if you are using groundwater. Numerous waterborne disease outbreaks have been attributed to viruses, though it is sometimes difficult to determine the exact source of contamination or the specific virus involved. Examples of viruses found in drinking water include hepatitis and norovirus. Protozoa are unable to reproduce on their own. Humans and animals act as hosts for reproduction, and typically cause gastrointestinal problems or worse. We usually find these organisms in surface waters and groundwater under the direct influence of surface water. Although they are typically not as prevalent as bacteria, protozoa are still a major concern. Examples of protozoa found in groundwater are Giardia and Cryptosporidium. Let's find out more about E. coli and the total coliforms that are referenced in your drinking water test results. Coliform is a common name for a group of bacteria. They are found in the feces of humans, warm-blooded animals, and in soil. Coliform bacteria are not necessarily pathogenic or dangerous to humans. However, coliforms are generally found in greater numbers and are hardier than other pathogenic bacteria. Therefore, the presence of coliforms is used as a possible indicator of fecal contamination, as well as the presence of other pathogenic microorganisms associated with fecal contamination. For drinking water to be considered safe, there cannot be any total coliform or E. coli found in the water sample. Total coliform and E. coli tests are done to detect the possible presence of pathogens in drinking water. The absence or low level of coliforms does not guarantee your water is free of other microorganisms that could cause a public health risk. You must test your water frequently to reduce the risk of contaminated water reaching consumers. The location of all Ontario public health units can be found online. Contact your local public health unit if you have concerns. Now let's review the regulation that well drillers are required to follow when installing and maintaining wells, and the different types of wells that deliver water to our homes. Owners and well contractors have legal responsibilities for ensuring the protection of the province's groundwater when drilling a well. Ontario Regulation 903, made under the Ontario Water Resources Act, sets minimum standards for the construction and installation of new wells. The regulation also sets rules regarding the qualifications of well contractors, the education and licensing required for well technicians, disinfection requirements, and well records. The complete well regulation can be found online. There are 4 common types of groundwater wells in Ontario: drilled, dug or bored, shore, and sandpoint wells. The water table depth and nature of sediments are key factors that determine the type of well to be constructed. Drilled wells are constructed using a drilling rig and a drill bit. There are many different types and structural differences depending on the aquifer. Current legislation requires that the well casing should extend a minimum of 40 centimeters above ground level and 6 meters, or 20 feet, below ground. The well casing serves as a house for the pumping equipment as well as the wall of the well, protecting the well from contamination or cave-ins. Dug or bored wells, often hand-dug in the past, are now constructed primarily with excavation equipment such as an earth auger. The borehole is then lined, or cased, with masonry or concrete. Dug wells can only be installed when the groundwater is close to the surface, 9 meters or 30 feet deep. The well casing must be covered with a solid, watertight well cover so that surface water and other foreign materials cannot enter the well. Shore wells, also known as infiltration galleries, are shallow wells installed near a water body in a shallow aquifer directly connected to surface water. Water is collected through a covered stone-filled trench that drains surface water to a storage well or tank. Soils surrounding shore wells provide minimal filtration. Sandpoint or driven wells are common in areas that have a lot of sandy soil, as well as areas with a high water table. The narrow casing of a sandpoint well is driven into the soil up to 6.5 meters. This type of well is susceptible to contamination and has a low water yield. Once a well is installed, you do not see all of the components that are required to deliver water to your home. In this diagram, you will see some of the key components of both drilled and bored wells. Let's look a bit closer at some of them. Wells installed since the 1970s have tags attached to the cap or casing that have a unique identifier linking the well to its record. The vented well cap allows gases to vent out and prevents a vacuum effect when your water level falls. Well caps also serve to prevent vermin and other contaminants from entering your water supply. The ground around the casing must be mounded and sloped away from the area, decreasing the likelihood of pollution entering the well. The pitless adapter is a fitting on your well casing that provides a frost-free connection between the well and your home. The annular seal is the opening between the casing and the side of the well that is filled with a mixture of cement, bentonite and sand to make a watertight seal. This annular seal provides protection to the aquifer. The well casing is a steel or PVC tube installed in the borehole to maintain the well opening and protect the well from collapsing. The static well level is the distance from the ground to the water in the well during non-pumping conditions. This level can be affected by changes in climate and pumping that is occurring in nearby wells. The jet ejector uses pressurized water from the pump to push water up to the pump. The well screen allows water to enter from the aquifer while preventing sand and other materials from entering the well. Next, let's look at pumps. Either a submersible pump or jet pump may be used to get the groundwater from below the surface, up through the well to your home. A submersible pump is a type of water pump designed to be installed in the well casing and submerged in the water. The motor of a submersible pump is hermetically sealed and is located below the intake screen to provide cooling. The pump works by pushing water to the surface. There are two types of jet pumps. The shallow well jet pump is designed for use in systems where the water is less than 25 feet in the well. Deep well jet pumps are suitable for deeper wells that have water up to 150 feet. The pumps are positioned outside the well and are often located in a home or other building. You will receive the well record from the well driller after installation. Let's review what a well record is, and how the information found here can help you with future troubleshooting and well maintenance. The following content has been provided by the Ontario Ministry of the Environment, Conservation and Parks or MECP. Well record forms may vary in appearance, but all require the same mandatory information. This is a sample record completed by the well contractor and given to the owner of the well after the final inspection. A copy also goes to the MECP. The well record provides valuable information on the well location, depth, types of formations encountered, well type, well materials, pump test results and any known water problems at the time of pumping. The record should be kept for as long as the well is used. The information is important if maintenance or repairs are necessary on the well. Let's look at a few key sections of the well record in detail. This section contains the well address and owner information, which can help new property owners find well records on databases. Location information includes the street address and the city, town or village of the property. The original geographic township, concession and lot must also be reported if the well is in an area where such information exists. A map showing all property boundaries must be provided. At least two measurements sufficient to locate the well in relation to fixed points must be indicated. In this example, the well is located 100 feet north of Maple Ridge Road and 0.3 kilometers from Bradshaw Road. A north arrow must be included on the diagram. It is important to accurately record the location of the well. Inaccurate location information on the well record can lead to problems locating the well in the field. This section provides information about those responsible for constructing the well and must be fully completed. The well driller will record the depth at which water is found from the ground surface. Using our example, fresh water was found at a depth of 106 feet. By indicating the water is fresh, no taste, odor or color issues were found. In our example, the well has been drilled through topsoil and then several layers of granite. There are a variety of materials used for a casing, and the diameter may vary for each section. In our well record example, two measurements have been provided. From a depth of 0 to 22 feet, the inside diameter of the casing is 6¼ inches, made of steel. From 20 to 121 feet, the well is an open hole 6 inches in diameter. The static water level indicates where the water is in the casing. Typically, water drawn from a confined aquifer will have a pressure differential that results in the water level rising up the casing higher than the level where water is found. In our example, the static water level is 25 feet. When pumping has stopped, the water level is at 121 feet. The well driller has recommended a deep or submersible pump. The pump test results portion of the pump record is very important when it comes to maintenance required on the well, as it gives a history of the recovery time of when the well was originally tested. It also has the recommended pump setting depth and recommended pump rate. This information is required to have your job properly quoted prior to the work being completed. Depending on the ongoing demand on the well, it is often recommended to have a pump test done to determine the current flow rate and recovery status every 5 to 10 years. This portion of the well record gives the original readings of the well rates and recovery times, which is then compared with current values to determine if further maintenance is required. If you are plugging or abandoning a well, the details are included in this section. Information about the type of product used, as well as information regarding how far down the well was sealed, appears in the depth column. Annular space information can also be found in this area if the well is not being abandoned. Information will include the type of sealant installed in the annular space, as well as the amount of sealant used. Here we see that this well has been sealed with cement to a depth of 20 feet. If you do not have a copy of your well record, you can visit the MECP's Well Records webpage and search for well records by address or well ID or tag number. This will take you to an interactive map page. Alternately, you may also contact the ministry to have a copy sent to you. Well maintenance involves shared responsibility. Minor alterations can be completed by well owners. These alterations include such tasks as routine repairs including cleaning, changing well caps, shock chlorination, and performing startup and shutdown procedures. For major alterations, tasks must be completed by a licensed well technician. This includes cutting the casing, adding casing extensions, installing a well screen, changing the pitless adapter, measuring the well yield, well rehabilitation and well abandonment. Wells can present a number of challenges for owners. Corrosion of the well casing or screen results in large quantities of sand in the pumped water, impacting the water quality and equipment. Biofouling, often simply referred to as iron bacteria, can develop due to microorganism reactions and may allow non-pathogenic and pathogenic coliform organisms to take up residence within the well. Naturally occurring iron or manganese may cause aesthetic color and taste issues with the water. Well yield, defined as the sustainable rate of water flow that a well can draw continuously over an extended period, can be impacted by such things as increased demand from neighboring wells or clogged well screens. Next, we'll review when and how an owner would consider performing a well disinfection as part of maintenance or after an adverse water sample result. Under the Wells Regulation 903, disinfection is performed by the person constructing the well once construction is complete. Disinfection must also be performed as part of installation or reinstallation of pumping equipment, following the deepening or extension of a well, or when conducting other than minor alterations or repairs on an existing well or on equipment in a well. Disinfection is also required when total coliform is persistent after flooding, and when E. coli is found in the distribution system, for example following a pump repair. Disinfection may help improve yield if your well is exhibiting slime growth, or if a well has been left dormant. Public Health Ontario has created an interactive online well disinfection tool for public health inspectors, well contractors and well owners. The tool provides an easy way to calculate the amount of chlorine product required for adequate disinfection. The tool also provides procedures and precautions to take when disinfecting the well. Using information from your well record, enter the required information regarding your well's diameter, depth, and water level. Then, input your desired concentration of chlorine, which for a standard disinfection would be 50 parts per million, and lastly, add the percentage of chlorine. This number can be found on the chlorine container. Using the data we have entered for this example, the tool calculated that there is 534 liters of water in the casing. And to get a concentration of 50 parts per million strength of chlorine, it is recommended you add 584.57 milliliters of bleach solution. For the steps to safely and correctly perform a well disinfection, follow the instructions found at the bottom of the Well Disinfection Tool webpage. If you have additional questions, you can reach out to the Ontario Groundwater Association. For free homeowner water sample test kits, please contact your local public health unit. Thank you for watching this video. This video has been created by the Walkerton Clean Water Centre, an agency of the Government of Ontario. The WCWC is committed to supporting the owners, operators and operating authorities of Ontario's drinking water systems. Please visit wcwc.ca to find out more.